Okay, guys. Next, we have Pauli exclusion principle. As I already mentioned that the states, the state of an electron in an atom is completely specified by four quantum numbers, and they are the these four quantum numbers are the principal quantum number. One is principal quantum number n. The other one is orbital quantum number L. The second one, the third one is magnetic orbital quantum number ml. The fourth one is magnetic spin quantum number ms. Now these four quantum numbers basically are completely specify the state of an electron in an atom. So Pauli exclusion principle is all about these four quantum numbers. Pauli in 1925, yes, it's 1925, yes. In 1925, Pauli introduced a principle for the distribution of electron for the distribution of electrons in the atom. Before Pauli exclusion principle, there was no idea how electrons are distributed in different orbits or in different shells. But in 1925, Pauli introduced a principle for the distribution of electron in an atom. So it give us it govern the electronic configuration. What is Pauli exclusion principle? We can define it first. According to this principle, no two electrons, the principle is no two electrons in an atom exist in the same quantum state. What it means? It means that no two electrons, like in an atom we have many electrons. The simplest one is hydrogen, which is a single one electron. Then we have atoms with more than one electron in the periodic table. So in an atom, if whatever the number is, among those electrons, no two electron in an atom exists in the same quantum states. What it means? It means that no two electrons in an isolated atom may have the same 4 quantum numbers. Like we have these 4 quantum numbers n, l, ml, and ms. So no two electron in an atom may have the same 4 quantum numbers. If 3 of them are the same, but the fourth one will be different, then like if n, l, and ml are the same for 2 electron, then this ms will be different for them. If I can say that n, ml, and ms they are same, then L will be different for 2 electrons. So it means that no 2 electron may have the same 4 quantum numbers. This is Pauli exclusion principle. We will explain it in detail by distributing electrons in different shells, like by distributing electron in K shell, L, M, N, and so on. And we will see that how each electron has different quantum states, are different 4 quantum numbers. Now this principle implies that each electron in an atom must have different set of quantum numbers. Must have different set of quantum numbers. Like each electron have a different set of n, l, ml, and ms. Like if 2 electrons, let's suppose if 2 electrons have their quantum number identical, like if we found 2 electrons for that n, l, ml, and ms are same, like their quantum numbers are same, these two, then one of these 2 electron would be excluded from entering into the constituent of the atom. I can write it here. If 2 electrons have all their quantum numbers equal, if all their quantum numbers equal or identical, yeah, it's okay, then one of these 2 electron, like we have 2 electrons, they have the same quantum numbers, then one of these 2 electron must be excluded from entering into the constitution of the atom. Suppose we have, like there are 10 electrons in an atom, among which those 10 electrons, 2 of them have the same quantum numbers, n, l, ml, and ms value are the same for 2 of them. Then one of the electron we will exclude it from the atom, or we cannot, that electron cannot enter into the atoms. So that's why the name exclusion principle is. because they are excluded, so that's why this principle is called exclusion principle. Now, according to this principle, electrons must be arranged in systematic way. Like electron cannot arrange in a random way, but there will be a systematic arrangement of electron. And this idea comes from the facts that if the electron were crowded in a single orbit, suppose we have 10 electrons in an atom, and all those 10 electrons are, let's suppose, found in a single orbit, then the chemical properties of the element will not change with atomic number, because all the electrons are crowded in the same orbit. But this is not true, because we know that different atoms have different chemical properties. For example, if I consider element with atomic number, let's say 9, element with atomic number 9, there are hydrogen, chlorine, fluorine, etc. Because there are 9 proton in the nucleus and 9 electron in the outside of the nucleus. So atom with atomic number 9, they are hydrogen, chlorine, fluorine, etc. No, it's not hydrogen, it's halogen. It's halogen. And element with atomic number 10 are inert gases. Inert gases are those with atomic number 10. And similarly, element with atomic number 11 are alkali metal like sodium. So it means that the electronic properties or the chemical properties changes with atomic number. Like the atomic properties changes with the number of arrangement of electron in different orbits. Now, above this discussion answer the question that how electrons are distributed in an atom by the observed principle. So here we will discuss the distribution of electron in different orbits. Now, the Pauli exclusion principle give us the idea to calculate the number of electrons that can occupy a given subshell. For example, I will start from the first shell, which is K shell. Let's suppose we have K shell, and for K shell we have n is equal to 1. Value of n tell us about the subshell. Suppose we have K shell for which n is equal to 1, so in K shell we have only one subshell. If n is equal to 2, which is L shell, so it means that in L shell we have 2 subshell. In L shell we have 2 subshell. So we can say that the number of subshell in each shell is equal to the number of quantum number, principal quantum number. I can write it here. The number of subshell in a given shell is equal to the number of is equal to the principal quantum number is equal to the principal quantum number. If n is equal to 1, there will be only one subshell. If n is equal to 2, then there will be two subshell. If n is equal to 3, then there will be three subshell. Like for K shell, we have n is equal to 1. So there must be only one subshell, and it will be only S shell. Because if n is equal to 1, L can have how many values? N minus 1 values, which is 1 minus 1, which is equal to 0. So L is equal to 0. Like for n is equal to 1, L has only one value, which is 0. And ML values will be equal to 2L plus 1. We already discussed about it. So it will be 2 into 0 plus 1, which is equal to 1. It means that ML has only one value, L has only one value, which is 0. ML has only one value, which is 0. So ML is equal to 0 for L is equal to 0. And MS the magnetic spin quantum number has two values. One is plus 1 over 2 and the other one is minus 1 over 2. So there are two sets of quantum numbers now. Like for n is equal to 1, L is equal to 0, ML is equal to 0, and MS has one value, which is plus 1 over 2. And for n is equal to 1, L is equal to 0, ML is equal to 0, and MS is equal to minus 1 over 2. So it means that in K shell we have only one subshell, which is S shell. Like in K shell, there is only one subshell, which is S shell, and this S shell contain two electrons, one with quantum number this and the other one with quantum numbers this. So if there were a third electron, its quantum number will be identical to one of them. So which is against the Pauli exclusion principle. So it means that the third electron cannot be exist in the K shell. So the K shell is therefore complete or closed with two electrons. So K shell will be closed or will be complete with two electrons. Now let's move to the next value of principal quantum number. This was for n is equal to 1. Now we will consider the next value of the principal quantum number, which is n is equal to 2. n is equal to 2 basically represent L shell in an isolated atom. So n has 2 values, so it means that there will be 2 subshells. How we can get the subshells? So there will be 2 subshells in L shell. And this idea we got from this principal quantum number. Its value is 2, so it means that there are 2 subshells. Now, what are those 2 subshells? Now, L values, how many L values will be possible? L is 2n minus 1, which is n, 2n2, 2 minus 1, which is 3. So it means that L has 3 values. And L values started from 0, 1, 2, 3 up to n minus 1. So the 3 values are 0, 1 and 2. For n is equal to 2, L is equal to 0, 1, 2. So these 2 represent L shell. In L shell we have 3 subshells, one with orbital quantum number 0, which is S subshell, second with orbital quantum number 1, which is P subshell, and third with orbital quantum number 2, which is, so n has 2 values, yes, 2 subshells. So the 2 values are, sorry, this is not correct. The 2 values are L is equal to 0, 1. These are the 2 values. This is not correct, sorry. For n is equal to 2, L has 2 values, one is 0, 1. For n is equal to 1, L has only 1 value, which is 0. For n is equal to 3, L has 3 values, which will be 0, 1 and 2. So for n is equal to 2, L has 2 values, which is 0, 1. And we know that 0 represent S subshell and 1 represent P subshell. Now, we already discussed that for n is equal to 2 and L is equal to 0, we have magnetic orbital quantum number ml, which is value 0. We already discussed in the previous example, because ml has values 2l plus 1. So it has values 2 into 0 plus 1, which is 1. So ml has only one value, which is 0. And ms, the what we call it, the magnetic spin quantum number ms has 2 values. One is plus 1 over 2 and the other one is minus 1 over 2. So in L is equal to 0 means S subshell there will be 2 electrons, one with quantum number n is equal to 2, L is equal to 0, ml is equal to 0 and ms is equal to plus 1 over 2, and the other electron with quantum number n is equal to 2, L is equal to 0, ml is equal to 0 and ms is equal to minus 1 over 2. So if you look at here, both these electrons have different quantum numbers, different sets of quantum numbers. Now we will move to the next case. For n is equal to 2, then L has one more value, which is L is equal to 1. So it means that now we will calculate the number of values for ml, magnetic orbital quantum number. Its value is 2l plus 1. So 2 into 1 plus 1, which is equal to 3. So it means that ml has 3 values, and those values are 1, 0 and minus 1. 1, 0 and minus 1. And we know that ms, the magnetic orbital quantum number, spin quantum number, magnetic spin quantum number has two values, plus minus 1 over 2. So it means that L is equal to 1 corresponds to P subshell. So it means that in P subshell we have 6 electrons. In P subshell we have 6 electrons, one with quantum number n is equal to 2, L is equal to 1, ml is equal to 1, and ms is equal to plus 1 over 2. Second with n is equal to 2, L is equal to 1, ml is equal to 0, and ms is equal to plus 1 over 2. Third electron with quantum number, sets of quantum number n is equal to 2, L is equal to 1, and we have ml is equal to minus 1, ms is equal to plus 1 over 2. And the fourth one with quantum number n is equal to 2, L is equal to 1, ml is equal to 1, ms is equal to minus 1 over 2. The fifth one with quantum number n is equal to 2, L is equal to 1, ml is equal to 0, and ms is equal to minus 1 over 2. And the sixth one with quantum number, sets of quantum number n is equal to 2, L is equal to 1, ml is equal to minus 1, and ms is equal to minus 1 over 2. So P subshell contain 6 electrons, and their quantum numbers are given here. This is for first electron, this is for second, this is for third, this is for fourth, this is for fifth, and this is for sixth electron. So this is what we call it Pauli exclusion principle for n is equal to 2. And the next video I will discuss about n is equal to 3 and so on.